Hello, my name is Jennifer Dunnam. I am the manager of Braille programs for the National Federation of the Blind, and I am also the immediate past chair of the Braille Authority of North America. And it's really an honor for me to be among the presenters at this General Assembly. A couple of caveats before I get into my paper. Number one, because I know there are going to be other brilliant, or there will be brilliant presentations on technology. I apologize in advance if any of mine is repetitious, and also if any of it is out of date, because these were written some time ago, and since we had to postpone the General Assembly, some things may have changed. So I look forward to the questions and answers at the time of the assembly to get everything corrected. So this paper is intended to provide an update to a previous paper that I presented at the 2016 General Assembly, basically talking about notable developments in the accuracy or inaccuracy of electronic Braille translation in real time, and some challenges that remain. Because for many of us, any of us who are here, Braille is literacy, and some of the problems really can seem intractable at times, the economics, the education, the lack of awareness. But there really have been some great, talented people involved in the technology, involved in innovation to make changes. And especially now, as we look at the way that hardware for Braille, the economics of that is beginning to change, the barriers are beginning to fall because we're finding less expensive ways of making that hardware, it becomes even more important for us to remove the obstacles that are presented by inaccuracy in Braille translation software. And so many of these things definitely are correctable. And I look forward to the continued work to do that. So I just want to very quickly run through some of the highlights that I've written about in the paper, starting with some of the notable developments since 2016. The first topic that I have here is improvements in the LibLouis translation. The LibLouis open software is used to generate Braille in many products like JAWS, NVDA, Braille Blaster, Chromevox, VoiceView, Bookshare BRF files, and more. And since 2016, the improvements there have been great improvements. As of the writing of this paper, the current version is 3.12. I believe it's now up to something like 3.15. But the point remains that many of the screen readers in use today and the packages that use it are using earlier versions than the actual released one, because it takes a while for them to get deployed. The improvements that have occurred since 2016 include the correct display of a wider range of symbols, improvements to back translation, better application of handling of modes and contraction rules in Braille, and the like. And some of the major issues that need to be addressed yet are discussed later in the paper, but I, for one, am very encouraged by the active and ongoing development of the UEB translation in LibLouis. I think it's very encouraging. Another important development since 2016 is the amendments to the rules in UEB about the apostrophes and quotation marks. And I think many in this audience are familiar with this long story, but basically the apostrophe and quotation mark, the single quotation mark, use the same Unicode symbol in print often, but they're very different symbols in Braille, and it has caused a whole lot of work for people who are producing Braille and a lot of inaccuracy in real-time translated Braille. But the rules have been amended with the release of 7.6 of the rules of UEB in 2019. Some helpful changes have come to pass to make it more clear what is to happen with those, but also really encouragingly, I think, is that it gives guidance directly to software developers to assist with the application of the new rules. And I think that's really key in this age. Next topic of notable development is type forms, particularly in screen readers. For many years, they have employed a method of showing type forms that involves a pretty active effort on the part of the user. It involves the use of dots 7 and 8 and a notation at the end of a Braille line to show you where the type form starts and which it is, it really requires a lot of effort, and sometimes it's very easy to miss it during that, using that method. At the end of 2016, though, NV Access released a version of its NVDA screen reader, which renders the UEB type form indicators for underline, italic, and bold correctly in Braille when the speech settings are set to report the type form. Significantly, as of this writing, NVDA is the only screen reader that will display these indicators in real-time translation. I have to say I got kind of teary-eyed when I first found this because we've not seen that before. Subscripts and superscripts, however, don't display with UEB indicators, even though those are spoken with speech in most screen readers. So that's something to continue to work on. Also in 2016, since 2016, a method was implemented in Duxbury Braille Translator for mapping the transcriber-defined type form indicators to any applicable type forms in a document, so that the specified indicators will be applied when the document is imported from Word to Duxbury. So for example, if you have strike through, we don't have a defined Braille symbol for that, but you can map the symbol to a transcriber defined indicator ahead of time so that those will show up, and that's great. Another development that's not shown in the paper, but I think is very helpful to point out, is that in the BRF files that are generated by Bookshare, they've done a lot of work to ensure that the type forms, italics, underline, and such are indicated there, which can be pretty important if they're left out. So that was a good development to see as well. The release of the Braille Blaster standalone translation software package from the American Printing House for the Blind has really been a game changer, because it's a package that's available without charge, and it has very robust and ongoing development by APH. It originally began as a package that was used for publishers' files, but as it has gone on, more files have been able to be used in it, like DocX and TXT and such. So the everyday user who's not trying to deal with publisher files can use it as well. There are some issues that they continue to work on, but they release updates regularly, so it's a good thing to see. Emoji in Braille. Some people laugh when I talk about this, but you know, it's becoming more and more important to get this right. With the version of Apple's screen reading software that was released in 2017, the names of the emoji symbols began to be displayed in Braille in lowercase letters enclosed in transcriber's notes indicators. So it's very clear, this isn't in the text, but this is the name of the symbol. So that's very helpful. A little bit later on, I'm going to discuss, though, another aspect of VoiceOver related to emoji, which should be considered. Translation from contracted Braille to print is the next sort of topic to talk about here. The ability to input using contracted Braille became available in NVDA in 2017 and is now available in most all of the screen readers. That was not the case in 2016, so that's very helpful. It's usable, but it is sometimes still pretty unreliable, particularly in screen readers with older versions of LibLouis. VoiceOver's system UEB table generally yields the most accurate back translation, but notably, it does not back translate fraction symbols like 1/4, as some of the other screen readers can. To move on a bit to some of the significant issues that continue to need to be addressed as I move through my time here. In most screen readers, there are sort of small errors that are just probably going to always exist. But in this paper, I'm going to be focusing on more global areas that cause ambiguity and discrepancy. My first topic is the dash, and people who know me know that I get a little nuts when I talk about this topic because it seems to go on forever, and it's a small yet ubiquitous error. The Unicode symbol for the M dash, which is 2014, in LibLouis has been assigned incorrectly, so that in Braille, when it's supposed to be showing .636, it displays as dots 5, 6, 3, 6. And it's everywhere. It's in all throughout Bookshare books. It's anywhere that you see an M dash in a symbol, and it seems like this is something that could be addressed. I know that one possible issue is that there's a little bit of inconsistency in the files of the UEB rulebook where dashes are used, and sometimes those are used for testing for LibLouis software. So I hope that we can find the channel to get that sorted so that our dashes will be correct. The check mark, another sort of small issue, but I pointed out because it's a newer, more recently adopted symbol. And as of the time this paper was written, I haven't gone through and tested since, but as of the time the paper was written, the check mark symbol had not been deployed in screen readers, except for VoiceOver. It has been corrected in the system UEB table being used in VoiceOver. There's another issue about numeric mode. When you have symbols, when you have letters that are followed by a period, followed by a number, the numeric indicator is often being placed before the period, so you get a numeric decimal rather than a period. And I'm talking about things like NO period number 9, where it needs to be NO with a period, and what we're getting is NO numeric indicator period number 9. Small sounding again, but it really does occur a lot. So hopefully we can get that sorted. There are also places where grade 1 indicators are missing that are needed. And I talk in a little bit more technical detail about that in the paper. There are specific words, and they apply with rule 10.9.5 is the place that needs to be worked out. Mathematics. In general, real-time Braille translation support for mathematics and technical material really remains far from complete, although it has seen some improvements. There is now more robust Braille support for MathML on the web, although for technical reasons, this seems generally to be true more for Nemeth code than for UEB renderings of mathematical content or mathematical expressions. Amazon's Kindle hardware applications have improved math support as well, but there's a lot of variables that can really affect the experience. Office 365 documents with math type content will now display in Nemeth, and also though in Word documents, individual symbols will display correctly in UEB, assuming that you don't get too much into the more complicated expressions, but those things are still being worked on, I know. LibLouis back translation is possible in some cases with mathematics using 6-key input, typing directly into Microsoft Word. Again, with a limited number of supported symbols, but those do include triangle, arrow, and things like that. So that's kind of neat to be able to type that in there. We do have an issue remaining where computer Braille code is being required for display and input when it's really not necessary anymore with the advent of UEB. I talk in the paper as well about Android, that although it does continue to lag behind in its accuracy, there have been improvements, and there was a pretty significant release in August 2019, which was 0.97 beta of the Brailleback program. So that continues to be developed as well. I did raise a concern in here about the fact that there's an alternate table that's been released that you can choose in VoiceOver, and it is using LibLouis Braille, but there are a number of things that don't work as well as the default system table that has been used previously. The use of enclosures that are non-standard or don't apply to, that do not abide by the principles of UEB can cause some ambiguity, and there are other issues like that that I talk about in the paper as well. So I think we should have a bit of concern if this is signaling that Apple will maybe discontinue maintaining the previous tables. I talk in here as well about some issues specific to Bookshare with spacing. It's not about LibLouis necessarily, but it's about spaces that get omitted in shared books, and that's discussed in more technical detail there. Just to conclude, however, though, I really want to laud the progress that has been made. I'm not a programmer, so I really appreciate the programming work that gets done and has continued to be ongoing. And I want to do everything. I know that all of us want to do everything that we can to continue to push for improvements, especially when so many of them really are correctable and can be improved. And it's going to be very important for literacy for blind people in the present and in the future.